So this week I'm only gonna output one video, mainly because the videos coming up, the next two modules, have to do a lot with each other, so I'd rather have those together than solving problems with right triangles and trig functions. So we're looking at this one. We're going to be looking at how to use trig as well as the Pythagorean theorem. Let's get started. Don't like hearing those, so I tend to skip it right away. As always, guys, hit this little folder for the resources. Using this worksheet is actually very helpful. That way you can identify this. I highly recommend filling this worksheet out. It's really going to help you when it comes to solving trig problems, especially with SOHCAHTOA and inverses. So the idea of an inverse is it takes a fraction and spits out an angle. Normally, when we're dealing with regular trig, we take an angle and it spits out a fraction. So inverses do the opposite. So let's get into the actual lesson. And as always, the regular guided notes are always very useful in helping figure this out, especially if you need review on the Pythagorean theorem. And this will break down the trig functions for you. So let's get into this. So our objective is going to be using trigonomic ratios and Pythagorean theorem to solve for right angles. So we're going to either solve for the side or an angle. So getting into this, if we use the Pythagorean theorem, we can use this theorem to solve for any side. We simply just have to square root it. So if we're solving for one of the legs, we just want to take the square root, but we're taking the hypotenuse squared minus the other leg squared. And this should look familiar. The C in itself should look like the distance formula. And this, like, we're literally taking this, we're subtracting the B from the C squared and taking the square root. That's how we solve for A. Same thing for B, except we're subtracting the A squared. So that one's pretty basic. So we can always look at the fact that these angles are similar. So because we know that the triangles should be, oh, this isn't a right triangle. Never mind. I thought this was a right triangle. If it was a right triangle, we could say they're similar, but it doesn't appear that they are. So we're going to see how to solve these angles. So let's get into the activity. All right, so go to right triangles, the Pythagorean theorem. So we're going to take a look at this GeoGebra assignment. All right, and we're going to follow the directions. Create a line perpendicular through point B to AC. So we want an AC line. So if we want to do that, we're going to do this construction tool. We're going to do perpendicular line. We're going to say we want it perpendicular to AC, and we can just click on B. And it should kind of snap into place there. You can kind of see it snap in there. Just going to click on B. So there we have a perpendicular line. I'm assuming they're going to want us to label it. Yep, they want us to label the point that touches AC. So we're going to grab this, get a point, and we're going to touch right there. And the program's automatically going to say it's the intersection. All right, so now we have that. Record BD and the measurement of angle BDA. What do you notice about ABC and ABD? Okay, so let's take a look at BD. So first we need to find the measurement of that line segment. So use our measuring tools, go to distance, click that, click that. Give me a second. I clearly didn't click on the right thing. Point B. That's not point B. Okay, having a hard time here. So what I'm going to do to make this a little easier is I'm going to hide that line because this is being a little difficult. So you can go to algebra And we're going to want to hide this line, so I'm just going to do this. And then I'm just going to create a line segment from B. Why isn't the stain hidden? There we go. Create a line segment from B, D. That'll make this a little easier. So hiding this line, in case you guys didn't see how I did that, you use this. I'm going to close this tool just to make it a little easier. So what you do is you're going to hit these three little dots, going to click algebra, and you're able to see this. This is a line, and then I create a line segment just to make this easier. So now I want to find the distance. Now this is a lot easier because instead of having to click B and D, which I was having a hard time with, I can just do this, and I get this 8.02. All right. So now I'm going to say that measure of BD equals 8.02. And it also wants me to find the measurement of BDA. So BDA, I'm going to close this. I don't need this anymore. So I need angle BDA. And that should be a 90-degree angle because it's perpendicular. So I don't know why the program is making me do this. Remember, when you measure this, you have to go counterclockwise. So this is clockwise. So counterclockwise would be this way. All right, so I'm going to do my measuring tools, go to angle, click B, D, A. Oh no. B. I don't know why it's giving me such a hard time right now. That is a point, isn't it? I don't know why it's giving me such a hard time right now. I'm going to go back to algebra to make sure. Yeah, that's a point. I don't know why it is being so difficult. Angle. There we go. I don't know why that was so hard. And I'm not sure why this is not a 90-degree angle. It should be a 90-degree angle, but it's off by just a little bit, probably just GeoGebra being GeoGebra. That's kind of frustrating. Let's take a look at my line segments just to make sure. Yeah, I don't know what's going on here. I'm going to delete this. Gonna make a line segment. B. Probably just GeoGebra being GeoGebra because there should be no reason that is not perpendicular. If it's perpendicular one way, it has to be 90 degrees. So probably just GeoGebra being weird. Just GeoGebra being weird. I'm gonna say it is 90 degrees. So because GeoGebra is being weird, I'm probably gonna guess that this is supposed to be 8. I'm just gonna round it to 8. I'm gonna round the angle measurement as well because something's going on with GeoGebra right now. Measurement of angle BDA. I'm going to say that's equal to 90. I'm going to be fancy and put a little degree sign there. So that's the measurement. Based on the angle measurement, if you accidentally move B before your measurements, move B back to the position button. How do I do that? That's interesting. I must have accidentally moved B then. So I wonder if I can. Nope. I don't see how I did because of that. So I must. I don't know what's going on. Point D. I feel like point D should be at 1. So I'm guessing that's what's going on here. Let me see if I can fix this. There we go. I'm guessing there was something wrong with how I calculated everything. I don't know what, but that should fix everything. Yep, and that's a perfect 8. So I clicked something a little off. All right. Move back to initial point. All right, well, I created the line. So, don't know what that is. Create a line. You can measure the. What do you know about the angle measurements? They're 90 degrees. Use the Pythagorean theorem to find AD and DC. So we're going to find AD. So that's AD. So if we're doing this, we're going to do AD, AD squared equals 10 squared minus 8 squared, which would end up being AD squared equals 100 minus 64. Means that AD squared equals 36. Therefore, AD equals 6. That's all for AD. I didn't use the square root method because I prefer having it with the squareds. I don't know. It's my preference. You guys can use the square root if you'd like. I'd probably recommend it because that's how they're teaching it. So you would just put a square root over it. So next one we need to find is DC. So DC would be this angle right here. So if this is 8, we're going to do DC squared equals 17 squared minus 8 squared. So we're going to say DC squared equals 17 squared minus 8 squared, which that's equal to, I just basically copied and pasted to make it easier. Let me use a graphing calculator. Let me use a regular calculator here. 17 times 17, 289. I decided not to use the squared function just because I feel it takes longer sometimes. This was an easy thing to square. All right, now we're going to subtract 64. So we get 225. And an episode of Batman Beyond made me know that 15 times 15 is 225. So this is just 15. We know that this is 15. Show your calculations. So you have to show this in order to get full credit. So that's what I did here. Then find AC by addition. So ACE, we use the equation editor. AC equals BA plus DC. I forgot what side it was already. Yeah, DC. Oh, duh. A to C. So AC equals, we got 6 plus 15. 16. So AC equals 21. All right, and that's our work there. Submit that. And we can see our work here. So again, they use the square root method. All right, so verify your calculations in question 2. All right, so AB, what did we get for AB? Oh, I think AB was given to us. AB was 10 chord length of 4 different positions. Great. So I'm gonna use the original one just because why not? And I'm just gonna measure the side 2 just to make this a lot easier to calculate. Okay. So this will make everything a lot faster to calculate. Well, not necessarily calculate. We're literally just going to plug it in. So AD is 6. Didn't say I couldn't use the original one. BD is 8. So AB squared would be 100. Then that would be 36 plus 64. So which is 100. Now we're going to move this. So I'm going to move this. Oh, this is the downside to doing it the way I did it. Let me see if I can find this a little better. I'm going to see if I can make this work with the perpendicular line. All right. So let's see if this works. Perpendicular line. This line. Okay. And then point. Close. It is not matching up. I'm not sure why this is being so stubborn. It's clearly supposed to be at 7, 1. Let's see if zooming in helps. Really close, but I'm not sure why it's not doing point of intersection. Oh, you know what? Let me try this one. This might be better. There we go. All right. So use point of intersection. Apparently that snapping thing wasn't as accurate. This should be way more accurate. So using intersection. I've never had it give me that hard of a time before. So I've never had to use point of intersection, but first time for everything, I guess. And of course, it's going to give me a hard time now. Come on. There we go. All right. And everything's matching up a lot nicer now. If you want to click the point, come at it from the left, it looks like, and it'll be a little more accurate. I can't believe how hard of a time this thing's giving me. There we go. All right. And then, like I said, we're going to have these here to prove everything else a lot faster. guess I had it on select instead of distance. There we go. All right. That took way too long. All right, so now this is accurate. So now what I can do is I can move this B, move the B, and this should still work. I'm going to try to make the sides a little friendly though. So I don't want to have weird numbers. But that might not be helped. Yeah, it doesn't look like it's going to be able to be helped. All right, so we're just going to have weird numbers. All right, and then apparently gives us a function that lets us move back to the original position. So I'm just gonna plug in the numbers as I see them. AB is 8.51. AD is 6.03. BD is 6. AB squared 8.51 squared 72.42. 72.42. All right, and then AD squared. Oof. It's basically 36 plus 36, but because of that decimal place and this right here, we're going to want to do a little bit more work than that. So let me pull the calculator back out. Clear 6.06 squared 36.36 plus 36 equals 72.40 36. So there's a little bit of round off error. I'm sure this rounded up. This AB squared was rounded up, or I should say this 8.51 was rounded up, causing things to be a little different. Because I'm sure if this was rounded down, 8.5 would probably be a little bit closer to this, but it's probably 8.5 in some number. So 8.5, I want to square it, times 5. As you can see, it's a little bit of round off error there. All right, so let's move these again. Move. And it is really hard to grab that B, it looks like. All right, so let's move this again. And now time to record the new measurements. So 9.75. Remember, GeoGebra estimates it, so there might be round off error. There probably is going to be round off error. AD was 9.09, and BD was 3.55. AB squared, just so we can get used to using this calculator, 9.75 times 9.75. I'm going to put that at 95.06. 95.06. Then let's 9. Apparently the backspace doesn't work on this calculator. So I'm going to say that's 82.63. 3.5 squared. So clear 5 times 3.55. I'm going to say that's 12.6. And if I add that to 82.63, I don't know why this happens. Like, I don't understand how the Edmentum calculator messes up that badly. But again, we're only doing 2 decimal places, so let's see what this has happened. I worked with a student one time, and they had one where it was like 0.99, even though we like used all the tools to make it accurate. So Edmentum and GeoGebra aren't perfect, so there are going to be those chances. Oh, and I should have been doing these at the same time. Well, that just makes me go like I'm just gonna blaze through this really quick. So BC AB is 6.99, and then BD is 4.75. So BD is 4.75. AD AD is 5.13. 5.13. And we're gonna do clear this 6.99 times 6.99. And we're going to get 48.86. And here's this 5.13 times 5.13, 0.32 plus, clear this. We're going to do 48. Oh, not 48. 4.75 times 4. Oh my gosh, I really hate that backspace doesn't work on that. 4.75 times 4.75. We get this 107.17. 107.17. I'm just going to clear it because apparently this calculator like really hates doing work for rounding. It rounds when it doesn't even have to round. So, all right, and I get, whoa, that can't be right. I didn't even realize it when I did this. Something should have told me it was off. There we go. That makes a little more sense. Okay, 48.88. So there, like I said, there is that round off error, but it's actually, if you look at these equal signs, they're actually pretty close. This one's spot on because it was nice and even. Round off error causes a lot of problems. Let's look at this other one. BC 16.53. I said 3, but I meant to say 7. BC 15.87. BD 4.75. 4.75. One nice thing is because I did do this the same, I could do the plus 22.56 because it's that BD squared. Let's clear this out. 16.57 times 16 and 16. I hit the num block. This should be 274.53. And I try to avoid the round off error by using 2 decimal places, but there's still going to be round off error. Anytime you round, there's going to be a round off error. DC is 15.87. Oh, DC squared. 15.87 times 15.87. And I'm using the 10 key in case you guys are wondering why I'm able to type in the numbers so fast. I've gotten used to using the 10 key on my computer, so I'm able to just type it in really fast. Clear this. 251.86 plus 83.53. We get 275. And this one has probably the most round off error that I've seen. All these problems. It's off by like 0.9. The other ones were off by, this one's 0.02. This one's only off by like 0.17. This one's only off by point. Well, you get the idea. This one has the most. And I think it's just because we're dealing with bigger numbers here that there's more of a chance for round off error. I'm just going to move this C. Oh, I can't move the C. Dang it. I was hoping I could just move the C, but you have to move your B. All right, let's do this. All right, so BC is 12.3. BC is 11.42. And after a while, you'll get used to seeing this. Like, this is the bottom line, this is the line on the side. That way, when you snap over here, you know exactly where to look. 4.64. 4.64. Now it's time to use the calculator. Figure this out. 12.33 times 12.33. 152.03, because I'm rounding. Clear this off. 11.42 times 11.42. I get 30.42 plus that. I don't know which one does which, to be honest. Clear. This one's reset calculator. Well, I guess reset calculator is always better. 4.4. This is 21.53. And you can see I rounded up for both of those, so that's why there's definitely going to be some round off error here. Calculator. But actually, I think that one was just clear. Yeah, 51 equals 51, 151.95. That one's only off by 0.08, so not too bad. I imagine by this point you guys get the idea of what to do here. We're literally just grabbing that and moving it over. So I'm not going to go further in depth into this. This is pretty simple. I don't want this. Well, by the time I was talking, I could have finished this. I'll just finish it just to get it done. So alongside 14, 14.43. I'll do all the calculations at the end just to make it faster. 13.69. And 4.57. 4.56. Yep. Let me move this over. 16.32. And 15.53. And 5.02. Okay. And time to start doing some squaring. 14.43 times 14.43. I get 208.22, almost rounded up, but not quite there yet. 16.32 times 16.32, 266.34. Right, and clear this. 13.9 times 13.59. 7.41 plus 4.56 times 4.56 plus. Well, I did times. See that this gets repetitive really fast, and I know you guys have to do it, so that's why I was like, can't really ask you guys to do it and then not do it myself. So I hit the unlock button again. All right, and do some addition. 1 plus 20.25. Okay, and that gives me 208.2. That one was really close. All right, so going to the next and the last one, 15.59 times 15.59, 243.02. 5.05 plus 5.02 times 5.02, 25.2 by a large margin. And this would be 0.2 plus 43.05. And again, I'm just adding these numbers together. 268.25. Pretty close. All right, so we're just verifying that all of these work. So the Pythagorean theorem would work for these because we have two separate triangles here, two separate right triangles. This would also be a right triangle. I didn't measure it, but that's it. This was all review. Gave myself a 5 because it's all review. You guys should know the Pythagorean theorem by now. All right, so moving on to this. You can use the Pythagorean theorem to find unknown sides of a triangle. We already know this. So here's what we're doing now. We're doing an example here. Grab this. All right, so has a parcel of land that is 120 by 120. The land is planted in Bermuda grass surrounded by a fence, so his cattle will not ruin the grass. He decides to split the fence into two halves and rotate the cattle every 30 days. He plans to build a fence diagonally, so from here to here. Find the nearest feet to split. So in other words, we're doing the A, B, and we're trying to find C. So that's all we're doing here. So if we're doing that, we are going to do this A squared and this B squared are the same. So after I do 120 times 120, since these two numbers are the same, I'm just going to multiply this by 2, because this and this squared plus this squared is just this squared times 2. So I'm just going to multiply that by 2 to get that, and I need to take the square root of it. So I'm going to take the square root of this number, and it says it wants it round to the nearest yard. Oh boy. So these are yards. Okay, so we're going to round to the nearest yard, so that's 170. There we go. And it shows the work right there, which you guys can't see because I drew a big old picture. There we go. All right, so now we're going to do the next problem. So inverse trig functions. So trig functions, like I said earlier, it takes an angle. So we're going to take angle A and we spit out a fraction. Inverse trig functions are going to take that fraction and give you the opposite. So if you click this little hyperlink right here, it actually pops open a little chart that helps you here. An inverse function, they also call it arc, and for some reason they have the another way of writing it is to the negative power, or it looks like it's a negative. So for example, arc sine is the same thing as saying sine inverse. So arc is an inverse. So that little -1 isn't an exponent. It's actually a symbol for inverse. All right, so let's get into the actual practice. So this right here, for example, when we use the sign, it gives us this decimal, which is a representation of this fraction right here. And using the inverse sign, it would actually spit out 40 degrees. This one has a lot of decimal places. I'm pretty sure the Desmos calculator isn't that detailed. During tests, I want you guys to use, go to Desmos. I said Desmos calculator. I meant to say Edmentum calculator. During the test, obviously you won't be allowed to use this. So I want you to go to desmos.com. On Math Tools, go to Scientific Calculator. And if you go to function, this is where you're going to find your inverse functions and your tangent functions. So going here, let's go to the next one and try to solve some problems as soon as this loads. I'm going to pause it while it's loading. Sad part is the pause only took like a second. All right, so now we're going to look at this. So here's our activity. Let me close the old activity and that one. So here's our activity here, and it wants us to find this fraction. So AC over BD. So we're going to use the fraction, the equation editor. What was it? What was this? AC over BC. AC, so 250 over BC? Yep, BC, the hypotenuse. So we're going to do 250 fraction, 250. I don't know where all those other numbers came from. And 305.19. 305.19 there. And then we're going to do, so we're going to do the another fraction. This one's going to be, oh, I see what we're doing. Sine. So now we're going to do cosine of B. So we're doing cosine of B. Cosine of B would be adjacent, so 175, 175.05 over our hypotenuse was 305.19. 305.19. Imagine we're going to do tangent, except we're going to do tangent, so AC. So do this. I think they want the decimal, but I'm just going to do the fraction. And I'll show you how you guys are able to just use the fraction also. 175. Opposite over adjacent. And what we're going to do here is, unfortunately, this is a very weak scientific calculator, so I'm going to use the Desmos calculator. And we're going to do sine inverse of this fraction right here, 205, 205, or 250, sorry, 250 divided by, what was it? 305.19. 305.19. When you're switching back and forth between tabs, be careful because for some reason Edmentum moves it to the next tab. So if we do this, we get about 55 degrees. So this gives us about 55 degrees. Let's take a look at this one. So now we're going to do cosine. This over, I'm going to do cosine inverse of, I always forget these. I have a very bad short-term memory, guys. I'm sorry. Over 305.19. That wasn't me remembering it. That was me literally looking at this function over here. And we get about 55 again. So we're rounding this. So we get about 55 again. And then we're going to do tangent inverse. Tangent inverse. What I'm doing, in case you guys are running, I'm literally just typing in on the calculator instead of pushing the button, because me moving and clicking, I feel, is slower than me actually typing it out. But I think that's kind of nullified by the fact that I just explained how I did that. But it was faster at the time. All right, and that is also 55. So this proves that angle B should be 55. Now we're going to try for angle C. So in other words, we're doing AB over BC. Well, AB over BC is this one. And this you guys should remember from the fact that they're complementary functions. Oops. Want this. Control C. Control V. Cool. And I'm going to copy this one. Nope, nope. Oh my gosh, why is it so hard to do this? There we go. Probably could have typed it out in the amount of time I'm spending trying to figure this out. Oh, this one's actually backwards. So I'm actually going to have to fix this. It's easier to type in 250. All right. And now I'm going to do all of these, but now they're kind of in reverse. So I'm going to do sine, inverse. Oh my gosh, I slowed down on this one. Inverse of 175.05 divided by, what was that, 305.19. And we get 35 degrees, which makes sense because if you add these two, it should equal 90. So I'm just going to say that's 35 degrees. I'm going to try this again. Again, you guys should probably realize by now it should be the exact same thing for all of these. I'm just proving it because that's what Edmentum wants you to learn from this. Again, we get 35. It's just a little off. Next one is tangent inverse. And this one's going to be upside down of this. So it's 175.05 divided by 250. And again, it's all 35. So this is also 35 after we round it, and this is also 35 after we round it. Moving here, what do you observe from the angle measurements despite the inverse functions of the interior angles of the triangle being 180? What? Show the sum of the angles equal 180. Oh, okay. What do you observe from the angle measurements despite using different functions to calculate B or A? I should say angles B or A. Despite using different functions to calculate B or A, all of them have the same result after rounding. 90 plus 35 plus 55 equals 180. I don't know why they want you to show your calculation, but there's a calculation. All right, and now what are we going to do here? Click refresh button until the angle angle B is a right triangle. Click this one until it's a right triangle. I don't know what that means. Click refresh button until did we already have that? Oh, angle B is a right triangle. Okay. Refresh this. Refresh this. All right. Angle B is now a right triangle. So now we're going to do the same thing, except we're doing it for cosine of A and sine of A. Oh, could we be any more repetitive? All right, guys. So let's knock this out. So BC over AC. So BC 1. I'm just going to type it in the fraction. I'm not going to use the equation editor. I had no idea it was going to be this repetitive. 163.83 over AC. AC is 200. So I know this is over 200. And I know opposite. So I know this is 163.83 divided by, I need to find the adjacent now. So the adjacent of what angle? Adjacent of A. So that's 14.72. 14.72. 14.72. These are going to be opposites of each other. This is at least easier to copy. And this will actually be easy to copy into the other formula as well. I said formula, I meant to say calculator as well. And this should be 114.72 divided by 163.80. Okay, so time to solve this. So I'm just going to go ahead and start copying these. If you double click it, it'll get all of the thing up to the dash, and then you can just shift arrow to get the rest of it. So I'm going to do sine inverse of this, and I get 55. So this is 55, and I'm sure you can assume that the rest are going to be 55 after copying, but I'll do it anyways just to show you. Be 55, and then tangent 55. They're all 55. Yay. So if these are all 55, you can safely assume these are going to be all 35. I think they have you do this repetitively because they don't have an instructor explaining it. So what you'd observe with the angle measurements, the exact same thing, except now we're talking about A and C. So, boop. I'm going to change this from angle B to angle A. And it wants us to show that all the interior angles equal 180. And luckily, since all the angles were the same, we don't really have to do much else here. All right, and now we're going to hit refresh until angle C is the same. All right, so refresh, refresh. All right, cool. Now we have angle C as our right angle. So let's plug all of these in. They are different sides, so you do have to do this again. We're going to do for angle A first. So opposite over adjacent, or opposite over hypotenuse for sine. Opposite is there a way for me to just copy this? No, there is not. 5.75 divided by 115.47. Might as well copy this into the cosine of the other one. Copy this into here. Now all I need is the adjacent. This is the hypotenuse. The hypotenuse is the same for all of them. That's why I'm able to just do this quickly. And obviously these two are backwards. And that's 100. So this is at least easier to type in. All right, and I'm just going to solve for it once. After that, I'm just going to repeat it because there is literally no point in repeating it. We kind of proved that point already. The sine, I have a feeling, yep, this is 30. So if this is 30, I didn't know it was going to be 30, but if this is 30, then this has to be 30, then this has to be 30, then this has to be 60, then this has to be 60, and this has to be 60, and I assume they're going to do the exact same thing. Yes, they are. Prove that they're equal to 180. So unfortunately, we can't copy the same thing because it's not the same angles. So we can do this, and I'm going to change the angles to A or B. A, change this to B, and proving that they add up to 180. So 30 plus 60 plus 90 equals 180. Submit this. Have I been submitting? I don't think I submitted this one. I did submit this one. And you can see that they're kind of saying that the whole decimals, I don't feel like it's necessary to go that deep into decimals. All right, so 5. This was very repetitive. Might as well spell correctly. Lessons from before. All right, do that. And I didn't submit something. This one. Cool. All right, moving on. So this is just showing us how if we take sine of that, it gives us AC. And if we take sine inverse, it's going to give us angle A. All right, so moving on here. So we need to find what angle A is given this fraction. So we're going to do cosine of that. So we're going to do cosine inverse. 340. Oh, I didn't erase this. Stop it. Oh my gosh, clear. Okay. Cosine inverse of 340 over 1,000. We get 70. About 70. There's round off error, of course. Boom, 70. Because we have to use cosine inverse. Moving on to our next one. All right, so here we're going to be able to use trig functions to solve for given sides. All right, so let's move on to the next activity. So let's write trigonomic ratios. Let's see what they want us to do. In GeoGebra sketch, so here's a sketch. You'll use a sketch. William has AD is 120, is already established. Yep. Is 120. They will sketch using the width of the kite. Find two congruent right angles. What is AC? So we need to find AC. So from here to here. So we know that AD is 120. So in other words, we are saying that this is 60. All right. We know that that's 60. We know that this is 60. Is it asking us to use trig functions to find AC? They're two congruent triangles. Okay, with across two, using the width. Do that. Do we know any of the other angles? You'll sketch to find across the bottom, which is labeled on the sketch using the width of the kite and the fact that they're two congruent angles. What is AC? Oh, that's 60. It's the triangles are congruent. I thought this was a lot harder than we had to do. Congruent, AC equals CD. Therefore, x plus x equals 120 plus x equals 120, or 2x equals 120. So AC equals 60. Just to give some explanation to it, they might explain it here. It's equal to half. Same thing. All right, and state that angle is a half. So angle sine of ABC is a half. How do we get that? Sine of ABC is 1/2. Okay, so sine of ABC. So sine of ABC, sine of this angle is opposite over hypotenuse. So this is 1/2 ratio-wise. ratio-wise, it's 1 over 2. So if this is x, then this has to be 2x. And since x equals 60, then I don't like this. I want this to go away. Go away. Then this side has to be 2 times 60, which means this side is 120. All right. So since the two right angles make a congruent sine of, but yeah, they're obviously the same. What is AB? Okay, so sine of B equals AC over AB, which is equal to 1/2, which is equal to 60 over 2 times x. Therefore, AB is twice the size of AC. You guys don't have to do this. This is just me kind of explaining all of my work. So basically 60 is half of whatever the bottom is. Therefore, AB is twice AC, meaning it is 120. Then the definition of sine for AB. We already did that. AB. Didn't say DBD. I think Edmentum made a mistake. They're supposed to say DB for this. So you could technically say the same thing, but since they're asking me to solve for AB twice essentially, I'm just gonna leave it like that. All right, so the inverse trig function of ABC. Using the inverse trig function, what is the measurement of angle B? So we're going to find the measurement of angle B. So in other words, we're going to say sine, give me a second here. You can actually use the sine inverse thing here to make it a little easier. Sine inverse of 1, let me use a fraction. So we're going to use sine inverse of that equals, let's use our Desmos calculator for this. Sine inverse, I'm just going to put 0.5 instead of doing a fraction. 30 degrees. So sine inverse is equal to 30 degrees. Boom. It's the same thing. So boom, we found that. Using AB, what is sine? AB, show your work. CAB, CAB, CAB. Oh, they're asking us to solve for. They're asking us to solve for this angle. So that one we're just going to use sum of angle theorem. So we're going to say that 30 plus 90 plus x equals 180. Or we can essentially say that x equals 180 minus 120. I added these and subtracted it. Therefore, x is equal to 60. And I'm just using x just for a general variable. So there we go. All right. Let x represent angle that or that. Use the trigonomic functions to solve for x 3 decimal places in different ways. What? Let x represent BC. Okay. So let me erase everything that's on the board. Let x represent BC. X represent BC. Okay. Oh, I see. And now that we know that this is 60 and this is 30, we can solve for the rest. All right. BC. Solve for x in 3 decimal places. Solve for x, 3 decimal places, BC. And what did we say this was? I think we said this was 120. All right. So, in other words, I'm going to say, I don't know why we're doing this, because we had to get that information for the other one, so whatever. All right, so I'm going to say that sine of, I don't know, I guess I'll do opposite over hypotenuse. So I'll say sine of 60. Sine of 60 equals x over 120, fraction x over 120. And another way of writing this is 120 times sine, not sin, sine of 60. Let's say x equals, just to make this look nicer, x equals that. So this is x equals, here's my calculator, 120 times sine of 30? Are we using angle 30? Angle 60. And we get, that's not right. Did I do this? It should be right. This is 120. Oh, we don't know what this is. Duh. Oh, okay. This makes a little more sense. So I'm going to solve this using the Pythagorean theorem and the other one. Okay, I was super confused right now. I'm going to say 104, 103 point. Oh, it says decimal places. We haven't solved for this yet. Find 3 different ways. Oh, 3 different ways. Okay. Now I see. How many decimal places? 3 decimal places, 3 different ways. Okay. 0.923. So there's one way by using sine. Now I'm going to use cosine. So in order for me to solve this using cosine, I have to do cosine of 30, and it's my adjacent. Right, so this is my adjacent. I couldn't use cosine of 60 because that would be this side. I'm solving for x. So I'm going to use this, and I'm going to say this is equal to, where's my fraction? X over 120, which means that x equals 120 times cosine of 30. And that should give me something very similar. So I'm just going to alternate this to be a cosine. And I'm going to change this to 30. And I get the same thing, 103.92. It's basically the exact same thing, but I'll do x equals 103.923. All right, now we're going to solve it using Pythagorean theorem. So according to the Pythagorean theorem, what we should be doing is, let me put this in the equation editor. X up squared equals 120 up squared minus 60, control up squared. This is equal to x up squared equals, let me use my calculator, 120 times 120. Ooh, 14400. That makes sense because 12 times 12, 14400, doubling the zeros. And if we do 6 times 6, we get 36, double the zeros. X up squared equals calculator minus 36, double zero. 10800. 10800, right? And we're going to take the square root of this. And we get same thing, 103.923. And by doing that many decimal places, you see that a lot of that round off error was not even a problem. Boom. All right, and then you'll see all three methods right here. I'm just going to give myself 5. This was just review of the last activity. All right, cool. And now let's move on. And this is just saying that there's so many ways for us to solve for angle sides of a triangle. So let's do this. So cosine of A, so let's find out, we're trying to find out what BC is. Find BC. BC. Well, we know if this is 8, then this is 17. I'm just going to use Pythagorean theorem for this one, to be honest. 8 squared, or 17 squared minus 8 squared, the square root of that. So just to kind of square root of 17 squared minus 8 squared is 64, so I'm not even going to bother doing that. So this is 15. This is supposed to be my 8 squared. So this is just 15 right here. Boom. And they show it right here, 17, blah, blah, blah. You get all this. And that's your answer. So we're just using the Pythagorean theorem here. We could have used other things, but the main idea here was it was adjacent over hypotenuse. So our hypotenuse had to have been 17. So that was the big reveal here, is the hypotenuse. All right, solving right triangles. You looked up ways to solve this. So let's do our next activity. Oof, gosh. This one I think is very interesting. So I'm going to go into the right triangle solver. I'm not the biggest fan of this thing. So let's see what we have here. So what are we going to do here? We're going to generate a new problem using this program. Will determine we properly constructed a problem. So we're going to solve for an acute angle using sum of angles. So in order to do this, we want to, give me a second, we want to figure out an acute angle. So we either want to solve for alpha or beta. So I want to solve for, let's say, alpha. All right, so that means this is 90. So I have to figure out what my beta is. I'm just going to pretend that this is 30 and find selected value. And this thing says find angle. So what do we have to do here? Given information. So find angle A of the right triangle and find if angle. So we're going to say that beta B equals 30. So our given is B equals 30. And they want a screenshot of this. So what we're going to do here is try to get all this in one thing. Oh, one thing you can do is you can link this. You can grab a link. Click here to verify. Copy and paste it. Not sure what that does. But there's a few things you can do. You can screenshot it. I use the snipping tool. You can always use control, what's it called? Control and that little screenshot button. So if you guys still have trouble with screenshot on Chromebook, and what you do is you do Control and this little button right here, controlling that button on your Chromebook. I'm gonna use my snipping tool to make this easier. Where's my thing? So what we're gonna do here is I'm gonna use my snipping tool because my snipping tool just makes this so much easier to do. I'm gonna grab this. Here's my problem. I'm gonna save this. Call it capture one. You guys can see the Kahoot pictures I use. So capture one. And I'm gonna insert my image. Where's my capture one? I thought I put capture one. Where'd it go? Oh, I have it saved in Kahoot pictures. Well, I'll fix that later. Desktop, Kahoot pics, capture one. There we go. Next, I have to solve for a side. So if I'm solving for a side using Pythagorean theorem, so get rid of this. And I think, what's this? Report, PDF. You could generate a PDF if you want to make a problem. So let's do another one. So I want to calculate a side. So I'm just going to say leg A. So I'm solving for side A. So if I'm using the Pythagorean theorem, that means I need my C. So I'm going to make a C. I'm going to make that, let's make that 5. And I'm going to make this, and I'm going to need the other side. So if I'm for leg A, I need leg B. So I'm going to make that 4. I'm going to click find value. So what's given? Given is B equals 4. I'm going to say B equals 4, comma, C equals 5. And then I'm going to do the same thing, copy and paste my screenshot. So go here. I'm going to call this capture 2. I'm going to put it on the desktop first of all to make it easier to find. Capture 2. And I'm going to go into insert image, go here, go to the desktop, capture 2, boom, uploading. There we go. Next, we need to find an acute angle for sine. So if we're looking for sine, we're trying to find alpha or beta. So acute angle. So I'm going to say let's solve for alpha. And say solve for alpha. So if I'm using sine, I'm going to need my opposite and my hypotenuse. So I'm going to need an A and a C. So I'm just going to call this 3 and 5. And you'll notice I keep using 3, 4, and 5. That's just to make it easier on me. So 3, 4, and 5. I just find those angles pretty easy to do. So let's see if this works. This thing should tell you if you mess up, by the way. So looks like this works. It's a weird angle, but hey, it works. So I'm going to say that A equals 3. So A equals 3. I'm going to say that B, C equals 5. And using definition of sine, and this did use sine. So you can always see that this is working. Gonna take another screenshot. I'm gonna call this capture 3. So scroll all the way up to here, and you're going to keep having to scroll more and more and more the more images you put in. And I meant to click this one in image from my computer. Capture 3. All right, now I need to find a side. So in order to find a side using sine, so I'm either going to want to solve for A or the hypotenuse. Notice that they never tell you if you need to solve for hypotenuse or that. So I'm just going to close some of these out. I'm just going to solve for the leg. I think solving for the leg is easy. And I need an angle. So if I want opposite, I'm going to need my alpha. So I'm going to say that my alpha is, we can pretty much make any angle. I'm not going to type in the same angle. I'm just going to do this. And this found it out very, very easily, actually. Wait. Oh, no. This means I didn't do it right. So I kind of gave it away by typing in my alpha. What were we solving for? We're solving for a side. I don't want my A. I want to solve for leg A. There we go. I'm solving for leg A. So I'm going to make this my hypotenuse. I'm going to make it 5, and I'm going to make my alpha. So if I want to solve for the side A, I need my alpha, so it can be opposite over hypotenuse. And I'm going to say that's 30. So there we go. We had to use sine. So that's a good example of this. This honestly takes up too much room. So what I'm going to do is I'm going to do Control minus on my keyboard. That helps you zoom out so you're able to take the screenshot. So I'm going to do this. And I believe this is capture 4. If not, it'll let me, I'll see right now when I try to save. Control S. Yep, this is capture 4. So capture 4. And before I do anything else, I'm going to want my size to be the same. So I'm going to do Control plus. To go back in, I'm going to do this. I'm going to go to insert my picture. File, capture 4. This solves it. It wants my given. So my given was C equals 5 and alpha. I'm going to say alpha equals 30. Did I type them in right over here? I'm starting to wonder if I did. Oh, I use big B and stuff. Okay, that's better then. I'm going to use a capital A then for this one. Capital A. Sum of angles. That was easy. That one was easy. So this is the first time I've used an angle in a while. So I got confused. All right, so now I need cosine. So I need to find an acute angle using cosine. All right, so I need to find an acute angle using cosine. So I'm going to use cosine of alpha. So I don't need alpha. I need to solve for alpha. And I need the adjacent. So I need my B. I'm just going to put a 4 here. And I'm going to calculate that. And this should be using cosine. Well, it's using Pythagorean theorem. That means I messed up somewhere. Oh, I need to solve for alpha. Angle alpha. And I use cosine. So I know I did this right. All right, so let me do this. So I'm going to do my screenshot again. All right, and I wish I could just Control V, but unfortunately it doesn't let me do pictures. I have to scroll up. Wrong one. Pictures. Did I save it? I don't think I saved it. 5. If you need to refresh this, just click somewhere else and then click back and I'll refresh it for you. Obviously, it wasn't there the first time because I forgot to save it. All right, now I need to find the side using cosine. So if I need to find the side using cosine, that means I need this angle and I want to find B. So I don't need B. I'm just going to put 30 here for alpha. Find the value. Oh, you know what? I forgot to put my givens here. So my given was B equals 4 and C equals 5. And then for this one, I forgot to change this to a side. So I want to solve for leg B. There we go. And we see that they're using cosine, so we know we did this right. And we have an issue here. It's too big again. So again, we're going to zoom out one more time, and that gets everything. So do a new picture. Again, you guys, I know I haven't said it in a while, but you guys can just use the screenshot option. I'm just doing this just because I already have the tool. I'm not sure if there's a tool for Chrome. I'm pretty sure there is. I just haven't looked one up, and I keep forgetting I can't copy and paste into Edmentum. So I'm going to do this, do that. Cool. And then I'm going to say that my givens are, since I had a given alpha, I'm just going to say A. I'm just going to do capital A to show that it's alpha. That and I believe I had a lowercase c. C equals 5. All right. And I'm doing it for tangent. So tangent. So I need an opposite over adjacent. So I don't need a hypotenuse anymore. What am I solving for? An angle? All right, so I'm solving for an angle. So if I want to solve for alpha, if I want to solve for an angle, I'm going to say alpha, and my opposite would be A. So I'm going to put a 3 here, and then my adjacent would be B. So I'm going to put a 4 there. Find the value. And this is pretty simple. So we got this. Boom, boom. It should feel very repetitive. It's feeling repetitive for me. Save this. This is going to be 7. The benefit of naming them in order is you can see the numbers as you climb up. So we do that. I'm going to go here. I'm going to insert my picture. Keep doing equation editor. I'm so used to doing that by now. Go here. I have it set by date modified, so that's why it keeps showing the latest ones. So go here. All right, and our givens were A equals 3 and B equals 4. All right, and then our side. All right, it's time to do the side. So we want to solve for a side. So I'm going to solve for little a. So I'm going to delete little a. And now I need an angle, so I need my alpha. I'm just going to say 30 just to make it easy. And this should use a tangent function. And it does use a tangent function. And this one actually does fit. I was worried it wasn't going to fit because every time we were solving for a side, it wasn't letting us do it. We grab this, go over here, and we're going to say that our, save this. Final one. This should be our 8th image. So you guys should have a total of 8 pictures that you're submitting. 1, 2, 3, 4, 5, 6, 7, and 8. Which makes sense because one of them should be Pythagorean theorem. The other one should be sum of angles, and then 2 for every trig function. So 2 for every trig function, 1 for sum of angles, and 1 for Pythagorean theorem. Insert that, and then our givens. Oh no, it was not in this square that I clicked. Okay. And then our givens were B equals 4, and capital A equals 30. And all of these are under the assumption it's a right triangle. So I'm going to submit that. And I'm just going to say repetitive. This is very repetitive. One acute angle. I guess it could have done a little bit of work there. But hey. And 5. Very repetitive. All right. Hopefully you guys fast forward through most of that. And then this shows you just how you can use trig functions. All right, so now we're going to do this. So what's the measurement of angle A? So we have this 90-degree angle, and we have a few ways we can do this. So if we're doing A, we can see A, this is, I'm assuming this is 90 degrees. Okay, so if this is angle A, okay, A, we have opposite over adjacent. So it's an opposite over adjacent situation. So if we're doing opposite over adjacent, it looks a little weird, but this is the opposite of A. So we have the opposite, which is 21, over the adjacent, which is 25. So we can use tangent inverse here, because opposite over adjacent is tangent. So we're going to use tangent inverse. So let's get down to doing this part. Go to Desmos. I'm going to use scientific calculator. It's funny because you can tell that they made this after, they made the scientific calculator after the fact, because the graphing calculator is just called calculator. Okay, so we need tangent inverse of 21 over 25. And I get about 40. Does it say round to the nearest degree? Yep. So I'm going to say 40. Perfect. And then you see the work right there. Everything here. Going to move over. And here's our summary. So again, always review your summary and your guided notes to help you. The worksheet, I think, is going to be very useful in solving problems. And it's going to be very useful for the Kahoot. All right, guys. And then because any angle, if you have a altitude, these are all similar. So this can help you solving for these acute angles as well. All right, cool. So the Kahoots are going to be based off of just solving these types of questions, guys.